This is section 7.4. It is on, this is the wrong, yeah, that's right. 7.4, parallel lines and proportional parts. And a lot of information here, all easy, but a lot of information, both theorems and corollaries. Let's go through the theorems first. Triangle proportionality theorem says that if you have a line that intersects with two sides of a triangle, it divides it. If it intersects with two sides of a triangle and it's parallel to it, then it divides it into proportional parts. So what we know is A over C equals B over D. So you can almost think of this as a fraction bar and extend it out like that. There it is, A over C equals B over D. Okay, so it's going to be parallel to the third side, so obviously not the side it's intersecting with because it has to be parallel. And then you know this is true. All right, if you wanted to set it up as A over B equals C over D instead, for whatever reason, you get the exact same cross product, AD equals BC. So either way is fine. All right, then the converse of that is the next theorem, and that's saying if you know A over C equals B over D, then you know that these two lines, E and F, are parallel. Okay. All right, the triangle mid-segment theorem, 7.7, we actually went over this back in chapter 5, if you guys recall. If a segment's endpoints are the midpoints of a triangle, then we know that that segment has to be both parallel to and half the length of this. And we can go over why that has to be true later. That's because of you've got similar triangles here. This, actually, we can go over right now. So this triangle and this triangle would have to be similar with a 1 to 2 scale factor. If this is the midpoint of this side, this is half of the whole side since these two are congruent. All right, the same thing over here. You've got a reflexive angle over here. So by SAS similarity, the triangles would be similar. Therefore, that 1 to 2 ratio would carry out from this horizontal side of this small triangle and the horizontal side of the big triangle. Hopefully you got that. But as long as you know that these are midpoints, then this segment is going to be half the length of that third side, x to 2x, half the length, as well as be parallel to it. All right, a corollary is just an extension of a theorem. There are two of them here. So this corollary, 7.1, proportional parts of parallel lines, says if you have 3 or more parallel lines cut off by 2 or more transversals, the segments formed are proportional. So once again, A over C equals B over D. So you might say, well, that looks a lot like a triangle proportionality theorem, and that's basically an extension of that. A corollary is an extension of a theorem. And if we have these two segments, these two transversals intersect, then we'd have a triangle. And even if they didn't, even if they were parallel, this would still be true. A over C equals B over D. All right, then the congruent parts of parallel lines is really just an extension of this, which is an extension of triangle proportionality theorem. Only difference here is, instead of saying that just that they're proportional, if these are congruent, then these have to be congruent because of they have to be proportional. In this case, specifically, it's a 1-to-1 ratio. Therefore, you have to 1-to-1 ratio between these parts as well. All right, congruent parts on one transversal. That means you have to have congruent parts on the other one as well for them to stay proportionate. All right, a lot of information there. That's all the theorems and corollaries. A couple of practice problems now. All right, over here, we are asked to find a few things. All right, so this uses the triangle mid-segment theorem because you've got, if these are congruent, then we know F's the midpoint of AB. These are congruent, E is the midpoint of AC, and D is the midpoint of BC because these are congruent. And they've got two of the mid-segments drawn in there, EF. We're talking about the big triangle, okay, triangle ABC. EF's a mid-segment because it's connecting the midpoints of AB and AC, and ED is a mid-segment because it's again also connecting the midpoints of AC and a BC. Okay, so now we're asked to find AB, EF, and AFE. Oh, AB is just going to be double the mid-segment. All right, so this is the segment that's both parallel to this side of the triangle and half the length. So we know that that's true. Those are parallel. And half the length part is applied here. So this is 5. So AB has to be 10. All right, EF is going to be half of this side. So this big side of the triangle, BC, is parallel to EF. But again, we're going to apply the half the length part here. This is 18. So this is half of 18. This is 9. Right here. Let me write this in here as well. This is 5. This is 5. 10's that whole thing. And the last part, angle AFE. Okay, so this angle over here. So now we're going to apply the parallel part. This angle is congruent to this angle because they are alternate interior angles. There's a transversal, FE, formed by parallel lines. Okay, this is parallel to that, so therefore they're going to be congruent. So AFE is 87. All right, and then the next problem. Okay, this is this theorem over here. If you guys can still see that. The proportional parts of parallel lines. So you've got your 3 or more parallel lines cut by 2 or more transversals. Well, 2 in this case. So these streets, Larch, Maple, and Nuthatch, are parallel to each other. So the parts involved are proportional. This way you can maybe do with mental math. Okay, this is twice as big as this, so this has to be twice as big as that. This is going to be 32. Or if you want to set it as a proportion, you can either go 26 over 13 equals x over 16, or 26 over x equals 13 over 16. Just be consistent in how you set up your proportion. So both these are going to work. You'll see you're going to get the same cross product. Either way, you're going to get 26 times 16 equals 13 times x. Work that out. You should get 32. So as long as these two pieces are diagonal from each other in the proportion, or catty corner, and same thing with these two, you're going to get the right answer when you work it out algebraically here, or like I said, this window, you can probably figure out with mental math. All right, that is the fourth section of the chapter.